Welcome to our second Carbonyl video. In the first video, we saw how carbonyl compounds are prepared. We saw some of the physical characteristics, including how the boiling points are related. But in this video, we're going to be talking about the reactions that carbonyl compounds undergo. Now, the reactions of alkanals and alkanones are very similar. As a matter of fact, most reactions alkanals would undergo, alkanones would also undergo. However, there are few reactions, like very few, that alkanals undergo, whereas alkanones would not undergo them. And the reason for this is very simple. It is based on the fact that, if you remember what we said in our alcohol videos, when we looked at oxidation of alcohols, we said when primary alcohols are oxidized, they first become alkanals, which can further be oxidized into acid. But when secondary alcohols are oxidized, they become ketones, and then ketones are not easily further oxidized. So the ease of oxidation of aldehydes or alkanals and the difficulty we experience in oxidizing ketones is what we utilize in chemistry for differentiating them. So when we want to differentiate alkanals and alkanones, we therefore would employ oxidizing agents. And we expect that these mild oxidizing agents would act on the alkanone, convert it into the alkanal now, convert it into an acid. Then for the alkanone, the oxidizing agent, especially if it is mild, will have no effect on it. So we'll talk about that difference, how we can differentiate them. But it's also possible to differentiate alkanals and alkanones from other organic compounds. There's one reagent we commonly use, and with that reagent, of course, you have alkanals and alkanones reacting with it, but other organic compounds will usually not react with it. So we'll talk about that also in this video. So let's get started. The first reaction we are going to look at is the reaction between carbonyls and Grignards. Grignard reagents, as you are aware, are compounds of formula RMGX. So we say they are alkyl magnesium halides. Now, when carbonyls react with Grignard reagents, what do we get? The carbonyl compounds, I'm going to divide them in this case into methanal, other alkanals, and then alkanones. So on this board now, I'm going to put the first structure up there is methanal, so HCHO. Then beyond methanal, on the second line, I have drawn something to represent all other alkanals. Of course, the general formula of alkanals is RCHO, so that's what we have here. Then on this last one, we have alkanones, RCOR. Now these are carbonyls, and in each case, they are going to react with Grignard reagents. So we have R, MgX, and then on this side, I have H+. So the reaction is acid catalyzed, that's why I'm putting H+ there. On this one, I have RMGX, of course, H+ still. And then finally, I have RMGX, and then H+. Now, to help you visualize easily what is happening in these reactions, I am going to represent the R part of the Grignard reagent in lowercase, that's small letter. So you'd allow me remove these now, the R's, and replace them with the lowercase r. So R. So this is not done in chemistry actually, but we're just trying to use it to show you how this reaction would take place. For ease, we would normally say that for this reaction, to draw your product, you use this hydrogen. You let this hydrogen combine with that oxygen, like that were the whole mechanism really, so that you get H, C, then OH, and then H. So what has happened here is H has joined O, and of course the only way O can accept that H is to let go of one of these bonds, so that the positive charge that the H brings will now be on this carbon. So that carbon is now open to nucleophilic attack. And the nucleophile from here that is going to attach there is the alkyl group, the R. So what enters under here is R. Look at that compound. What kind of compound is that? Yes, it is a primary alcohol. I discussed this reaction in some detail earlier when I talked about alcohols. So if you have not watched my alcohol video, do well to visit the channel. That's if you're not on the channel right now. It's on YouTube, Dr. Quinty. Just search that channel. It's one word, no spaces in between. So you search that, look for the alcohol video, and you see this reaction in some more detail there. Then in this case, what we have would be written as R, C, then OH. This is H, and then down here we have R. That's also an alcohol, but this time the alcohol is secondary. Again, if you don't know how to classify alcohols, primary, secondary, tertiary, you'd have to watch my alcohols 1 video. I showed the classification there. Then, in this third case, what I get will be written as R, C, OH, and then R, then down here R. This is a tertiary alcohol. So in summary, what do we get when carbonyl compounds react with Grignard reagents? Answer, we get alcohols. If the carbonyl compound is methanol, then you get a primary alcohol. If it's any other alkanal, sorry, I said methanol there, that's methanol. If it's methanol, you get a primary alcohol. If it's any other alkanal, you get a secondary alcohol. And then for the alkanones, they give us tertiary alcohols. So having said that, I'll move past that reaction so that we don't waste too much time, especially because it has been discussed in a previous video. Let's talk about how carbonyl compounds react with derivatives of ammonia. So I'll make space for that. Now, when we say derivatives of ammonia, we may need to talk about ammonia itself first so that we can appreciate what we call ammonia derivatives. Ammonia itself is written as H, N, H, and H. This is ammonia. And this could be written as H2N, then H. Same thing. H2NH is NH3. Now, the derivatives of ammonia we're talking about here are formed when this hydrogen of ammonia is replaced by different groups. And these derivatives include H2N, OH. So in this case, the H has been replaced by an OH, and this compound is named just by naming the 2 functional groups it contains. OH is hydroxyl and NH2 is amine. So we call this hydroxylamine. Hydroxylamine. Then we could also have a derivative like this, H2N, NH2. That's an amino group occurring twice, but we call the compound hydrazine. So this is hydrazine. Then in this hydrazine, I could remove one of these hydrogens on this side and replace it with a phenyl ring. In that case, I'd have H2N, NH, then that is attached to a phenyl ring like that. That substance is called phenylhydrazine. Phenylhydrazine. Then we could also have another derivative like this, H2N, NH, and then we have this. Alright, so that is called, okay, this is still phenylhydrazine. Now we want to modify this phenylhydrazine a bit. On carbon 2 here of the phenyl ring, I can add a nitro group, NO2. Then on carbon 4 there, I could also add a nitro group. So it means that this compound will be called 2,4-dinitro phenylhydrazine. 2,4-dinitro phenylhydrazine, and that compound is also called Brady's reagent. So Brady's reagent is 2,4-dinitro phenylhydrazine. And I remember telling us that it's possible to differentiate alkanals and alkanones from other organic compounds. This is the reagent we use. So if we were to differentiate carbonyls from other organics, we use Brady's reagent. This last derivative of ammonia I'm going to put here is H2N, NHCONH2. That compound is called semicarbazine. So we have semicarbazine. So semicarbazine is H2N, just like the others, NH, and then the rest is CONH2. So it appears to have come from hydrazine by replacement of one of the hydrogens on this side of hydrazine with CONH2. Now, having put these derivatives here, I want to react them with carbonyl compounds, alkanals, alkanones. Interestingly, when they react with carbonyl compounds, the products they form have names resembling the names of the derivatives themselves. Like for semicarbazine, when it reacts with carbonyl compounds, you are going to get a semicarbazone. So it's just the I that becomes an O. In the case of 2,4-dinitrophenylhydrazine, it becomes 2,4-dinitrophenylhydrazone. In this case, we get phenylhydrazone. In this case, we get hydrazone, just the O-N-E. I-N-E becomes O-N-E. But in this case, we don't get hydroxylamone. Instead, we get a group of compounds we call the oximes. So oximes are produced when carbonyls react with hydroxylamine. It's time to write reactions. Let's write equations for all of these reactions. So these are the derivatives. If you need to learn them, you could pause the video for a while. Otherwise, here are the reactions. So this first case, here is a carbonyl compound. These two ends of the carbonyl have not been defined. So we don't know if it's RH, that's in an alkanal, or RR as in an alkanone. But we just know it's a carbonyl compound, and it's the carbonyl group we need for this reaction. So when this carbonyl reacts with H2NOH, that's with hydroxylamine now, so we have H+, the reaction is acid catalyzed. We have H2O from here, so this is H2O being collected from that point. So it means I can write plus H2O already. Then, if I bring the rest of these two molecules together, if I bring everything else together, I'm going to get something that looks like this, double bond NOH. That compound is called an oxime. So when we start with an alkanal or alkanone, we get the alkanal oxime or the ketone oxime. So oximes are formed when carbonyls react with hydroxylamine. So beyond that one, you could have the same reaction, or a similar reaction rather, for this compound. We said this compound is called hydrazine. So if you were to draw the hydrazone, how would it be? The same mechanism. Water is removed from here. That means I'm going to write that, double bond N, then the rest here will be NH2. So that's the hydrazone. All I've done so far is remove this H2 and that O. In this third case, this is C and that's O, plus H2N, NH, pH. pH there stands for that phenyl ring. I just didn't bother to write it. So that at the end of the day, I'll have this C double bond N, then NH and pH. This is called a phenylhydrazone. We said so before. Then we have two more. This is the next one, carbonyl plus H2N, NH, pH, NO2 bracket 2. This is like a straight hand writing or straight hand form of the structure we drew before as Brady's reagent. When these two react, you expect to get double bond N, then NHPH, then NO2 bracket 2. So that's our product. That product is called a 2,4-dinitrophenylhydrazone. Then what about the semicarbazone? How do we draw the semicarbazone now? So this is CO, then we have H2N, NHCO, NH2, so that when they react we get double bond N, NHCO, NH2. So in the exam, if you are given any alkanal or alkanone, irrespective of what it looks like, just follow the same pattern. Remember how the reaction occurs. That H2 comes from the ammonia derivative, while O comes from the carbonyl, and together you can get water from them, so that the rest of the two molecules can be joined together, and it's easy naming your product. We've said that your product is named according to the derivative you use just by changing the "in" to "on", except in the case of hydroxylamine, where we get something with an entirely different name, an oxide. So this is the reaction between carbonyls and ammonia derivatives. Again, if you would need to pause that reaction and master it a bit, you're free to do so. Alright, at this point, let's look at the next reaction with hydrogen cyanide. What happens when carbonyls react with hydrogen cyanide? They react to give us a group of compounds we refer to as the cyanohydrine. Cyanohydrines are formed when carbonyls react with hydrogen cyanide. Now, hydrogen cyanide is usually not put into that reaction directly. It's a very poisonous gas. So handling HCN may not be advisable, so that we could put in NaCN and HCl, sodium cyanide and HCl, so that these could react to produce the HCN, or we put in KCN and then HCl. When you see that mixture in a reaction, you could actually take it to mean HCN. So that if I were given a question like CH3COCH3 plus HCN, then I could write this reaction as CH3CH3O, so this is that compound, plus HCN. In this case, we could assume again that this H joins that O, so that it becomes OH like this, CH3. I'll write it properly as H3C, then this is C, then H3C. So this CH3 is what I have there, this is what I have there, it's the same thing. Then this C is that C. Now, because H has joined this O, I can put it there as OH, so that this C is now positive like it was before, and the cyanide becomes the nucleophile that will attach to it like this, Cn. So in the alternative, I could have written that reaction as CH3, CO, CH3 plus HCN, same thing, so that the H joins that O and I have CH3, C, CH3 and OH, so that finally the Cn, the nucleophile, attaches here. So that compound is called a cyanohydrine. Cyanohydrine, that's the name we call such compounds. Now the next reaction, which will be the last on this video, so that there will be a third video on carbonyls, is their reaction with alcohols. What happens when carbonyls react with alcohols? I'll show you that reaction here, but just before then, one, I want you to please note that the organic compound we started with here had how many carbons? 3. But the organic compound we're ending up with there has how many carbons? 4. So we say hydrogen cyanide reaction is one way of elongating an alkanal or alkanone. If you were to increase the carbon chain length of an alkanal or alkanone, using hydrogen cyanide is definitely an option. Now beyond that, let's look at their reaction with alcohols. I'll summarize that reaction first. What happens when carbonyls react with alcohols? Here is the story. For alkanals, when they react with alcohols, they do so in 2 steps. In the first step, the alkanal will give us what we call a hemiacetal. Then when that hemiacetal combines with another mole of alcohol, we get an acetal. In the case of alkanones, Commonly, they can combine with diols. A diol is a dihydric alcohol according to our alcohols 1 video. And these diols have 2 OH groups in their formula. It means therefore that unlike alkanals that will take OH from 2 separate molecules of alcohols, the diol supplies 2 moles of alcohols to an alkanone so that the alkanone can directly be changed into what we call a ketal. So ketal is the final product of alkanones reacting with diols. So look at this. Let's pick an alkanal. Let's say we start with the alkanal written as CH3CHO. That alkanal is called ethanal. Now for ethanal, if it were to react with an alcohol, let's say we use methanol, it will mean that I'm going to write CH3CHO. That's CH3CHO. Then that CH3CHO is going to combine with CH3OH, that's the alcohol, and this reaction is acid catalyzed. Now here's our assumption. In terms of the mechanism, we're going to make an assumption of how this reaction takes place. The assumption is that this H will protonate that oxygen so that we have on this side CH3, C, H, and up there OH. Then the rest of this molecule, CH3O plus, or CH3O minus rather, the nucleophile, will attack this carbon that is positive so that on this side I have OCH3. This compound you are looking at now is the hemiacetal we're talking about. So a hemiacetal is formed when only one molecule of alcohol has reacted. Now in the presence of another alcohol molecule, see what happens to our hemiacetal. So this is CH3C and then H, then up there OH and then OCH3. If this were to combine with CH3OH, another mole in the presence of mineral acid, the H in this case will protonate that same oxygen that was protonated before. That means I should be seeing something like CH3, CH, OCH3, and then up there OHH, because the oxygen has been protonated again by another hydrogen. Now this water breaks off. If we were to speak the pure language, we say water is a very good living group. So once we have this oxygen being protonated again, everything could fall off as a water molecule, leaving that position empty or vacant for the nucleophile to attack again. So there will be another OCH3. This kind of compound is called an acetal. So an acetal would always look like this, whereas the hemiacetal would look like that. So that is acetal formation, or hemiacetal and acetal formation by a ketone or an alkanal. In this case, we used an alkanal. So alkanals are the ones that form hemiacetal and acetal. Now for alkanones, we already said that they would form ketals. Remember, they are called ketones. So ketones or alkanones will form ketals. And I'm going to show that here. Once again, you could pause this if you need to. Otherwise, I'll use that space. For the ketones, when they undergo reaction with alcohols, we said before that they would react with 1 mole of a diol to give us the ketal straight. Now, one diol I can use for this reaction is this one. This compound is called ethane 1,2-diol. So this is ethane diol. Now, if ethane diol were to react with this alcohol, carbonyl compound, you remember that in the case of the initial carbonyls we saw, where we had something like this, the first thing that happened was that there was protonation of this oxygen, such that we ended up with a product that looked like this, OH, and then on this side we had OR. So one of the hydrogens from the alcohol, ROH, came to the oxygen, then OR entered this position. Then in the second step, the OH went such that we eventually had OR, OR. That was what happened. Now in this case, this H, that H, and this O are lost. So that if I come here to put CCOH, COH, HH like this, then when this O is gone with those two H's, we have these two oxygens now to interact with this carbon. That means I'm going to draw my product as this two, then C. So whatever you have here, in this case anyway, we have RR because we already said that what we are starting with is a ketone. So ketone RR, RR there. Then on this side I have O and I have O. What are these two oxygens? They are the two oxygens here. And what are they bonded to? This is bonded to carbon with two hydrogens, oxygen with carbon and two hydrogens. Then the other oxygen is also bonded to carbon and two hydrogens. The two carbons themselves are bonded like this. So it means we have H, 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 and H. This is exactly how alkanones form their own addition products. We call them ketyls. So this is a ketyl. The ketyl is formed when a ketone reacts with 1 mole of a diol. Now let me quickly remind you that there's another video I made on something like this. I called it protection of groups. If you were to protect a carbonyl group, one very good way of doing so is using an alcohol. That's acetal or ketyl formation. It is a way of protecting carbonyl groups. So you may want to look at that video on protection of groups. Most importantly, remember to like, remember to share this video. And for your friends who are not aware, videos of mine like this one on chemistry as well as some biology videos are available on my YouTube channel, Dr. Quinty. It's one word, DRQUINTY, no need for any spaces. You just search that on YouTube, and when you find it, remember to give us a like, remember to subscribe, and like I said, remember to share. Let your friends hear of this wonderful channel that is changing lives. So I'll see you in the third carbonyl video, where I'll talk about reduction of carbonyl compounds as well as the Cannizzaro reaction and the aldol condensation, which are two very important reactions that carbonyl compounds undergo. See you in that video, and thanks for watching.